Welcome to this presentation on coastal science applications with ENVI. Many of the global effects of climate change are more intense in coastal and high-latitude regions. Current longer periods of ice-free conditions in combination with a rising sea level and thawing permafrost can result in accelerated Arctic Ocean coastline change and erosion, as you can see in this little movie. Areas dominantly composed of ice-cemented peats and silt-rich permafrost have proven to be especially susceptible to rapid erosion. Scientists have measured erosion rates at the site along the Alaskan Arctic Ocean coast of 15 meters per year. The continental scope of these changes, as well as the remote and inhospitable nature of the study area, make geologic remote sensing techniques particularly well suited for studying coastal erosion along the over 45,000 kilometers of Arctic Ocean coastline. While it is valuable to determine current patterns of erosion, it is equally important to map historic rates in order to determine if coastal erosion is accelerating, if there are areas of emergent erosion patterns, or if what is currently measured is only a single instance in a complex and constantly shifting pattern of an overall balance of erosion and deposition at high latitude. Even at their most stable, coastal processes are dynamic and complex, making it especially important to ensure the best possible accuracy in a study of this kind. Remote sensing solutions in the earth sciences are often impeded by a lack of historic data and baselines, as well as issues in the systemization of accurate feature mapping. Applying image processing techniques to Landsat archive data allows for the possibility of a multi-decade map of Arctic Ocean coastline changes. Landsat data from sensors MSS 1-3 and TM or ETM 4, 5, and 7 provide imagery as frequently as every 16 days since July of 1972 and are well calibrated both radiometrically and geometrically. They are also freely available from the USGS EROS Data Center archive. Hand digitization of Arctic Ocean coastline changes over several decades would require an impractical amount of time and expense and would introduce additional error due to analyst differences in image feature interpretation. Classification and thematic change detection using image analysis software such as ENVI make it possible to get similar results to hand digitization with much less time and effort involved. The results using this approach can be extended and automated to stably map Arctic Ocean coastline changes in Landsat datasets distributed both geographically and temporally. From the Landsat archive, accessible at earthexplorer.usgs.gov, scenes were chosen by the path row information, and the scenes should be sufficiently free of clouds and ice. For this example, 2 scenes were chosen from the 1978 MSS data and a 2008 scene from the ETM Plus data in order to determine changes in erosion and sedimentation between the 2 years. In the first step, a classification was performed on the Landsat images using the classification workflow in ENVI. In the workflow, the image is loaded in the file selection dialog. For this example, we are using course training classes to separate the features. The training classes can be selected in the dialog by drawing polygons on the interface to represent land ice and water. After the initial classification is performed, the results can be cleaned up using smoothing and aggregation methods. The final classified image for the 1978 dataset is shown in this image. The same steps for classification can be used on every Landsat scene available with clear coverage of the study area. In this case, we used only 2 datasets, and this is the final classification for the 2008 dataset. You can see the ice formation in green. The classification images are then used to perform thematic change detection between each time step to isolate only those areas which have been classified as land, which later changed to water, in that case it would be erosion, and as well as water which was then later classified as land, or deposition. Each area of change has an attribute of both type of change, erosion or deposition, as well as a timestamp of when the change was recorded. The workflow allows you to quickly see the changes that have occurred in a preview portal window as shown here. The results of the thematic change detection workflow, you can see the dark green and olive are the erosion categories, whereas the light green applies to the sedimentation between 1978 and 2008. The results of the entire Landsat scene, showing both erosion and sedimentation for 2008, are shown here. Classification using course training classes has been shown in this example to reliably delineate shoreline by using only land, water, and ice classes. These classification results are sufficiently reliable and accurate to feed directly to thematic change detection tools for generating maps of both type of change in coastline morphology, erosion or deposition, and time of the change. Moreover, this methodology can be scaled in a completely automated fashion to handle a much larger continental scale of detailed coastline change analysis. Clouds, cloud shadow, and excessive ice cover on either land or sea can introduce significant error. This concludes the presentation. If you would like more information, please email us at info@excellusviz.com or visit our website at www.excellusviz.com or visit us on Facebook, Twitter, or YouTube. Thank you.